So, the stage is yours. Craig, Spence. Okay.
Everyone, I haven't done this in a while, so I'm excited. I'm really happy to be in a room full of people. It's been a while. This should hopefully be fun. So, hi, I'm Craig. There's my face. I'm from New Zealand. I live in Stockholm, and like I just introduced, I'm currently an engineer at Spotify. I'm on the internet. You can find me those places. Don't follow me. You can follow me if you want. It's regretful, put it that way. The slides are up on there, so if you want to take a picture of the thing and follow the slides on your phone, feel free. But today, I'm just going to tell you a little story. And it goes something like this. Chapter 1. A very helpful reindeer. It was nearing the end of winter in the kingdom of Arendelle. Sven the reindeer was feeling very productive. He'd been helping his friend, Kristoff, the royal ice master. Kristoff and Sven had been friends since they were very, very little. And it was their job to make sure that Arendelle had enough ice. Sven was always looking for ways to work smarter, and he could always count on help from his friend, Olaf the snowman. Less work means more time for adventures, and Sven and Olaf love adventures. Chapter 2. Sven's most magical idea. Trying to get my slides right. Sven and Olaf had two other very special friends in the kingdom. There was Princess Anna, and there was Queen Elsa. Anna was the brave, tenacious princess of Arendelle, and Queen Elsa was her big sister. Queen Elsa had amazing powers. She could sense the water molecules in the air around her. She could transform those water molecules into ice. And she could control that ice however she liked. Sven would never forget the day that Elsa explained her magic. I'm going to let you in on my little secret, Elsa began. You may have heard that any sufficiently advanced technology is indistinguishable from magic. But it's actually the other way around. Any sufficiently incredible magic is usually actually technology. And the technology that makes my snow magic work is called TypeScript. Now, Sven already knew TypeScript from his work running the website for the local sauna. And he just couldn't wait to learn more. Thank you for bearing with me on that one. Sven and Olaf wanted to use Elsa's ice magic to make Kristoff's life easier. And they'd figured out the perfect plan. They were really excited to share it finally with Anna and Elsa. Snort. Sven snorted. Anna was thrilled. That's a great idea, Sven. You can take Elsa's TypeScript ice magic and create a library that anyone can use. This is going to save so much time. Elsa couldn't wait to help. Let's do this, she said. Anna and I will help you learn all about TypeScript. Chapter 3. You can't freeze everything. Sven and Olaf got straight to work on their new library. They designed their ideal API. It had just two functions, freeze and thaw. You could take a thing, you could freeze it, and then you could thaw it to return it back to the original state. And they started building out the functionality. The freeze function would just be a nice little abstraction layer around Elsa's ice magic. Elsa was going to help write that down later. This is great. We're amazing, Olaf exclaimed. Anna and Elsa, what do you think? This is really good. Great work, said Anna. But do you want to make it even better? Asked Elsa. Let's talk about developer experience. What would happen if a user imported some magic fire and then tried to freeze it? Not a real question. We don't know what would happen. You and I know, said Elsa, that you can't freeze magic fire, but our users might not know that. If they were to try to freeze some magic fire, there would be serious, dangerous consequences, but our library allows it. It's our job as library authors to save our users from those kind of traps. Right now, we're using the any type. But that's actually okay. It's not so easy to see what the best way to type this code might be. We want to be able to freeze almost any input. Almost any, not actually any. But right now, the code says that we can freeze absolutely anything. Grunt, grunted Sven. That's right, Sven. We need to find some way to limit the kind of objects that can be frozen so that no one can freeze something that is unfreezable. One way we could do that would be to catch the problem at runtime, Elsa suggested. We could, in our code, simply check for an unfreezable property and then just throw an error. That would be fine, but we can do better. It would be better for the library user to know about the issue before they run the code, instead of having to wait for it at runtime. And that's where TypeScript can help. Anna, why don't you explain? So, TypeScript has lots of different types. There's all the primitive types like Boolean and string, and then there's all the built-in types like maybe array or date. And then of course there's a whole layer of custom user-defined types that we can add. And all of these types form what's called the TypeScript type system. One way to think about this is a bit like a Venn diagram. Humph? Humph, Sven? Not a Sven diagram, a Venn diagram. Anna laughed. Let's check it out. I'm sorry. So, we have all of these types, each of which do their own different thing. But they're all contained within the default type, which is any. The any type is what we would call the top type of a type system. It's a super type of all the other types. And it's a type for which all values are valid. Using the any type essentially tells TypeScript that any value can be assigned to a variable. So when TypeScript sees an any type, it basically just stops type checking from that point on. Sometimes that's fine. The any type can make our code really, really flexible, but it can also be dangerous, like in our case with the freezing magic fire. If the input is undefined, in this case, the code will break, but the compiler doesn't complain. It would be great for us to be able to express that to the user some way. So, we want our library to be flexible, but without the danger, asked Olaf. Is that even possible? Yes, said Anna. TypeScript gives us another tool for this. We can use the unknown type. Let's look at the Venn diagram again. We have the same diagram as before, with specific types in the middle, and any as the super type. But we can add another new friend in the middle called unknown. And so unknown is actually another top type of a system. It's also a super type of all other types, and all values can be assigned to a variable that is the type unknown. But it behaves a little bit differently. We can replace the any with unknown, and this time we will get a compile time error. We can't use the unfreezable property because the input might not exist. It can still be assigned to it, but when we compile it, we get this warning because we haven't handled unknown yet. So we need to fix our compile time error. We need a way for the compiler to decipher that unknown value. And one way to do this is to use a type guard. A type guard is a special kind of function that gives TypeScript hints about how to narrow a type. So to go from a wide type, like unknown, to a narrow, more specific type. So yeah, a broad type to a specific type. And a type guard is actually a runtime check. So it's a runtime piece of code that has some additional instructions that tell the compiler that it should map to a type. We use this special is keyword to say that when this function runs, if it returns Boolean true value, then the type will be of that specified is type. And so here we have a type which is defined just as the unfreezable type, which is an object with a property of unfreezable that is set to true. And so after we call that type guard, inside the result of that if statement, the object will definitely be unfreezable. And outside of it, we know that we don't know whether or not it is. But right now, this implementation's a little bit weird. We're talking about something that is not unfreezable. And then we have that double negative, and then we do all of our work inside the if statement. So that doesn't quite flow very nicely. Yeah, double negative and kind of a bit weird control flow. So it would be better, actually, if we could talk about something being freezable. And so, for this, TypeScript actually has another type to help. Let's go back to our Sven diagram. So, inside, we have our two top types. We have any and unknown, which again, all values are valid for those types. Then we have the more specified types inside the diagram. But outside of the circle, we have another type, which is called never. And the never type is the bottom type of a type system. So unknown and any are top types, and bottom and the never is the bottom type. And that is a type which has no valid values. There is nothing you can assign to a variable that is of type never that will be accepted by the compiler. We can use the never type to describe what a freezable object is. And so a freezable object is an object where the value for the unfreezable property can only ever be never. So if someone were to assign a value to unfreezable, even if that was false in this case, which is kind of weird, but still makes sense kind of, it would not be able to be assigned to freezable. Hopefully that makes sense. But what this means is that we can actually invert our type guard, and we can write it in terms of being freezable. So instead we've kind of flipped the Boolean. I think there should actually be an or in there instead of an and. That's my bad. And then in our control flow, we can remove the double negative. So it just reads a little bit more clearly, I think. But there's also another way that we can use the type never. And so that's as the return type for a function that never returns. As an example for that, a function that throws an error will never return a value. So it gets the never type, which kind of makes sense. And so in this example, we could have our if check, and inside the if statement, we know that our type is freezable. And assuming that we return inside that, if we get to the throw part of the code, we know that we've not got a freezable type because we had that never check. And so then there's another thing that kind of combines these two ideas called assertion guards. So assertion guards are a combination of the idea of type guards, but also functions that return never. So in this case, we're saying that if our assert freezable function doesn't throw an error, then we know that the return type is freezable. So any code that would execute after the function must be on a freezable type. So hopefully that makes sense. In this case, we can actually get rid of the assert statement altogether, and we know that if we passed an object that was not freezable, the user would get a thrown error, and so the code wouldn't run. This looks great, said Elsa, but we can go further. our input is still typed as unknown. So we're still depending on a runtime error. But we can restrict our input to the freezable type. So now we have runtime and compile time safety checks. Chapter 4, to be frozen. Sven and Olaf were delighted. Sorry. Well, said Elsa, we need to talk about what is involved with freezing something. I use a very obscure dialect of TypeScript that looks something like this. You'll just have to trust me that it works. We can simplify that down a little bit to understand what's going on. The function tries to run some magic on the object, and then if it succeeds, it sets the frozen property on the result. But now we've still got some really messy types to fix. We've got another unknown being passed in, we're casting to any, and then we're returning the result as unknown. Sorry. So we already have a freezable type, which is great, but we need to replace these unknowns and these any's. So we need a frozen type. The most basic version of that could look something like this. An object where frozen is true. But that doesn't really express what we mean. We want to combine the types of the freezable thing, whatever the input was, with the basic frozen type. We need a type that describes something that is freezable, but also has the frozen property. Yeah, so we want something in that little middle bit that is both. And again, we can use TypeScript to express this by using what are called generic types and intersection types. We're saying that if an object is frozen of type T, then it has all of the properties of T, the original type, plus the properties from the extra object. But let's dive in a little bit deeper. When you're dealing with complex TypeScript types, it can be useful to think about them in some kind of equivalent JavaScript syntax. You can think of a type as kind of like a function. Adding a generic type is like adding a parameter to that function. And an intersection type is, no, I am right, yeah. An intersection type is kind of like a typed version of an object spread. So you're getting all of the properties from the first thing and combining it with the second thing, like you would with spreading objects. And so now we can almost correctly express our function. We can replace all our any's and our unknowns with a frozen of type T. But do you see what's missing yet? It's okay if you don't. Because Olaf does. It doesn't say that the type of the input has to be freezable. Exactly. So for that, we need to express one more type relationship. We have our freezable type, but we need to express all types that contain freezable. And so just like any was a supertype of Boolean and string and array, we want to create a supertype of freezable. And the way that we can do that is we can use the extends keyword. So if we go back to our function analogy, using extends is kind of like specifying a type for that type parameter of the function. If that kind of makes sense. So before base type could just be anything, it was kind of like an any in the kind of metaphor. Here we're explicitly saying that it has to be of type freezable. And so we can also even set a default type for that type parameter. So instead we can say T must extend freezable, but if you don't give it anything, we're just going to assume that it's freezable. And in that case, in the kind of JavaScript mapping, it's like setting a default value for that value. So now we just need to add the generic to the freeze function, and it will be finished. So, putting that all together, we have a freezable type. So, an object that has an unfreezable property with any value can never be assigned to freezable. So that's us using our never. We have a frozen type. So a frozen type is the intersection of any freezable object and an object where frozen is set to true. So that's the result of our freezing function. We have this asserts freezable function, which is an assertion guard that takes an unknown input and throws an error if the object is not freezable. And then we have a freeze function. So that function takes a freezable input, checks with an assertion guard that it is freezable, freezes the object, and then it returns a frozen type. I just said for a lot. Hopefully that makes some sense. Olaf was very excited. "The library is finished," he said. "Come on, Sven, let's go show Kristoff right away." And before Anna and Elsa could even try to stop them, Sven and Olaf were out the door and on their way. Chapter 5. Too fast, too frozen. Olaf and Sven rushed to show Kristoff their library. "Hi, Kristoff," said Olaf. "Maybe." "We made a library to help make your job easier," snorted Sven. "We can use it to freeze anything you like, just like Elsa. And it will stop you from freezing anything that can't be frozen." Yay, compile time checks, runtime errors, woohoo. Kristoff was blown away. "You made this for me? Let's try it out right now," said Olaf. Now Kristoff is quite the rockstar developer, so he wrote a little script very quickly. But just as he ran the script, Anna and Elsa burst in. "Wait, stop," exclaimed Elsa. "We still need to write the Thor function." But it was too late. The library worked. Olaf was frozen. Sorry. Chapter 6. Do you want to Thor a snowman? Kristoff was devastated. "Oh no, what have I done? Oh no, I've frozen Olaf." "We need to move fast," said Elsa, "or Olaf could be frozen forever." Let's start with the JavaScript. We have the Thor function, which will just delete the frozen property of any object. And we'll use some assert frozen function to validate the input. Kind of make sense? The opposite of what we did before. "Can't we just add that everywhere and fix it straight away?" asked Kristoff. "No, it's too risky," said Anna. "We don't want something going wrong." "Sven, why don't you add the types to the assertion guard first?" Gulp, gulped Sven. First, Sven added the unknown type to the input. And then he made sure to cast the input to frozen before doing the frozen check. Finally, he added the assert statement to the return type. So this time we're asserting that the input is actually something that's frozen so that we know that we're not trying to re-thaw something and might melt it. "That's perfect," said Anna. "Clip clop," said Sven. "Now we need to add types to the Thor function. Kristoff, I need your help." So, we can start by adding a generic type for the input so that we can make sure that it has to extend frozen so that we know we're testing something that is already frozen. But I have no idea what to do with the return type. Help. So, Elsa's back to rescue us. We need to use TypeScript to extract the type of the original object from the frozen type. So this is the perfect time to use conditional types. Conditional types let us change type based on the state of other types. You have a condition, a type for if the condition passes, and a type for if the condition fails. A conditional type is kind of like a function with an if statement. So different types get returned based on the state of the condition. So yeah, in this type we kind of got the if statement and then the two different return types. But conditional types have one extra special power, which is type inference. Type inference gives us a mechanism to extract types from other types. So let's imagine that we wanted to extract the return type, the type of the return value of a function. We can write a conditional type called return type, which is actually built in TypeScript, but it looks like this, which takes a type parameter t. And so first we can check if the type t is a function with some number of arguments, doesn't really matter what, with some return type r. And then we can use the infer keyword to infer what that return type will be. If the condition passes, we return the r type. And otherwise, the condition didn't pass, so t isn't a function, so it doesn't have a return type, so we return never. So in this instance, we have some function called 1, which just returns the number 1. And if we were to query what the return type of 1 is, we would get back a number. We can do the same thing, say we want to figure out what the parameters of a function are. Again, this is built into TypeScript. So we check again if t is a function with some number of parameters, and this time we don't care about the return value, so we just use any. But we use infer p on the arguments spread thing. If that condition passes, we would return p. Otherwise, we would return never. And so now we have an add function, which has two parameters, so a and b, which are both numbers. Just adds them together, but that doesn't matter. If we were to use the parameters type on the add function, we'd get that tuple of number. So infer lets us pull type information out from existing types. We can use type inference to extract the type of a generic frozen object. So if we start with our type forward, we can check if t is some frozen thing. And we can use that infer keyword to figure out what the thing inside it was frozen. If the condition passes, so if the t that's passed in is in fact frozen, then we can return r. Otherwise, again, we'd return never. So if we have something which is water, and then we freeze it to ice by using that frozen type, and then we unfreeze it using the thawed type, this type will extract that inner water type out. So we can now get back to the original type object. Okay, I got this, said Christoph. I'll update the thawed function. I'll add the new thawed conditional type. I'll use thawed as the return type, and then I'll cast the result of the call to that original type. So that should invert the type, and we should get back to what we originally had. Come on, slides. That looks perfect to me. Let's save Olaf before it's too late. Chapter 7. That was weird. Christoph, Sven, Anna and Elsa all worked together to quickly write a new script. Thanks to the library's excellent types, they were very confident that the code was good. So they ran the script, and just like that, Olaf was back to his normal self. Oh my god, slowest GIF in the world. I'm just building tension, obviously. What? The internet is the best thing in the world. Olaf was back to his normal self. Nice. Hi everyone, my name's Olaf. That was weird. What happened? Oh, Olaf, we're so glad you're okay. So much has happened. Christoph, I think you'd better explain. Okay, I think we've got it. Ready, Sven? Sniff, sniffed Sven. This is the point where I need my ukulele. Gonna just go this way. Thanks. And also the part where I shit bricks. Oh my god. Did I break my slide with this? Oh, no. Oh, okay, I didn't. All right. I haven't done this live in a while. Let's see what the levels are like. Unknown is better than any. Sven, don't you think that's true? Yes, Ellie's too flexy, unknown's your new bestie, and never is pretty cool too. Generics are also quite useful for describing unknown types. And don't forget unions, conditionals, and inference. Your users will have a great time. That's right. Good types are worth the hype. And just like that, everything was back to normal. The end. Thank you so much. Hope that was fun. That was fun for me. Again, I'm on the internet. Again, the links for Joined In is on there. Feel free to rate. Don't feel like you have to. Tweet me if you've got any questions that you don't want to say now. But obviously, thank you so much. It's so much fun to do this live.
Thank you so much, Craig.
I don't want to break this.
Yeah, you want to. I think you have found a really clever way to teach about JavaScript also to not only adults but also child and so on. I really enjoyed that. So thank you for this experience, not just like talk.
Thank you.
Yeah, we have a question here.
Hello.
Hey.
Thank you for your presentation. For me, it was another level of presentation. Really amazing. Thank you. And especially in the last part, there was, I think, many functional concepts about types. Personally, I'm mostly an object-oriented programmer. So about the freeze function, I observed that you put both some constraints on generics to say this is freezable, and also you put a guard function together that in my mind they do mostly the same job, so it's not clear because you need both of them.
Yeah, so one thing that we have to deal with in the front-end world, especially if you're writing a library, is you can't actually assume that someone's going to be consuming it from TypeScript, right? So this library could be used by some haphazard JavaScript developer without the types. And we still want to make sure that they don't break the universe by freezing something that's unfreezable. So by having that assertion guard and the type guard, we can protect TypeScript users at dev time and JavaScript users at runtime. So it's kind of like a combination thing there.
Okay, thank you.
Yeah.
Other question, something?
Thank you. We have a question from Hupin about infer. It seems a short way to make it working without have to write the frozen object type. Is this correct, or am I missing the point?
No, they're kind of the opposite. How to explain this? So infer is one of the most kind of hard to wrap your head around bits of TypeScript. It only goes in certain places, so it only goes inside conditional types, and it's literally just saying if the type matches the shape of this kind of without the infer keyword, then I'm going to just give you the result of whatever that thing inside where the keyword should have lived is. I don't know if that made it more clear. But it's kind of the opposite part of defining a type. So you can define a type, which would be, say, frozen, and then the infer bit lets you say, TypeScript, you've got this type, can you tell me what it is? So they're kind of two sides of the same coin. Hopefully that makes sense.
Anything more? I have a question.
Hell yeah.
You showed something about TypeScript, but what about other developers that are using not TypeScript?
Lots of things. That's a great question. What am I using at the moment? I mean, I use React every day. I'm an Angular GDE, so I probably don't know where I'm meant to say that. Philosophically, I try to use as few things as I can so I can be good at those things. But yeah, I do use a lot of TypeScript for sure.
Okay, thank you. Yeah, yeah, Giuseppe here.
Okay, thank you. Great speech,
Thank
first
you.
of all. And just a little opinion about what you think about the new proposal of adding types to JavaScript, sort of types.
Yeah. I'm super excited for it. I think working in spec land is really hard. I have so much gratitude for the people that live in that land, but I think it's also their responsibility to kind of reflect what the community is doing, and obviously the community's opted into TypeScript in a big way. I think it's a pretty measured proposal. I don't think the idea of adding full types to TypeScript, we've tried that in the past, it didn't work. I think there's some opportunities for some absolutely wild stuff to happen in that little magic space where the types will go. I'm so excited to see what other things come up with. Obviously, there are still other things in the way of getting full TypeScript in the language. We've still got to deal with enums and stuff like that. So it'll be cool to see what happens. Thanks.
I have another question from Open. How generically infer union type works? Do we need a string literal property?
Say that one more time. Sorry.
Sorry, maybe
Let me read it.
if you read it yourself.
Okay, so I think I get what that means. So when imagine you've got a union of two types, and I think they mean you want to infer one part out of that. That doesn't have to be string types. You can do that with objects. I can't remember the exact syntax, but it's a little bit weird. Ask them to hit me up on the internet later, and I will try to write some more.
No more hands?
Can I get off the stage now, please?
Thank you so much,
Thank
Greg.
you.